Kia ora Year 11 and 12. In this video I'm going to do an optimisation problem. Get your pen and paper and you can work through it with me as we go. Now it's a little bit harder in some ways than the ones we've done in class because it involves the volume of a cone, and it goes like this. We're building a cone and we have to choose the dimensions of the cone. Okay, so we're told that the cone has a slant height of 22 centimetres. So while I'm doing this, draw yourself a nice cone in your maths book, and we're asked to figure out the vertical height that's going to maximise the volume of the cone. Okay, so find h, the vertical height that will maximise the volume of the cone. So the first thing that we need to do is to draw a picture of a cone. So there's my very bad picture of a cone. If you're really bad at visualising, go and get an ice cream cone out of the cupboard and have a look at it. The next thing we need to do is to say, well, what is the formula for the volume of a cone? So the volume of a cone is equal to 1/3 pi r squared h. And we've been told that the cone has got a slant height of 22 centimetres. So what's the slant height? Well, slant height in a cone is the height that's on a slant. So this dimension here is 22 centimetres. So we can think about what we're trying to find, the vertical height, as being this distance here. So the vertical height is that one there. You might already be looking at that and thinking, well, it's quite hard to see that in 3 dimensions, so we're going to try and draw a 2-dimensional picture here, and that's going to help me see the next step. So as you know, when we optimise something, we're going to differentiate the thing that we're trying to maximise, right, which is this. Unfortunately, this has got 2 variables in it. It's got r, the radius, put that on there, there's the radius, and it's got h, the vertical height. But we can't differentiate that until we've got it down to having 1 variable. So somehow we've got to find a link between r and h. And in earlier questions like the one about the farmer and the pig pen, that was pretty obvious from the question wording. But here we've got to look a little bit harder. So the key to this is thinking about the shape in 2 dimensions. So if this is my slant height, this is 22, we know that this thing here is the radius, and this is my vertical height. So picture this as being a triangle that's sitting in the middle of the cone. So I'm going to draw the cone again and just show you one more time. Where did I get that triangle from? So there's the centre of the triangle. So picture a right angle triangle going like that. Now if you look at that, hopefully you'll quickly see a link between the h and the r, and that link comes from Pythagoras Theorem. So we can write this down. The radius squared plus the vertical height squared is equal to 22 squared, which is 484. So here's my link that I need to eliminate 1 variable. So let's look back at my formula for the volume of a cone. We've got a choice with what we do next. We can either get rid of the h, or we can get rid of the r squared. And we're going to do one of those things by rearranging the Pythagoras equation. Now, by far the easiest thing to do here is to make everything, so make h squared, make r squared be the subject, so that we don't have r in my equation anymore. I'm going to go through that slowly on the next slide. Okay, so I'm going to say that again because I've just garbled that a bit. So this is my volume of the cone, 1/3 pi r squared h. And now we know from Pythagoras that r squared plus h squared is 22 squared. So I'll show you what happens if we do this a bad way. Suppose we look and we decide that we're going to get rid of the h. So here we'll do this. H squared is equal to 484 minus r squared. So h is going to equal the positive square root of this. Now I can take that h and I can put it into there. But you can see that that looks really, really hard, and we don't know how to differentiate that just yet. Wait for year 13. So we're not going to do it this way. Instead, what we're going to do is we're going to eliminate the r squared. So we'll start from the same place. R squared plus h squared is 484. But let's make r squared the subject this time. So r squared is 484 minus h squared. And now I can substitute that into here for r squared. And that's going to be perfectly fine to work with. So v is equal to 1/3 pi times 484 minus h squared times h. We're going to expand that and then differentiate. Sorry about the background noise. It's a TV set. It's not people doing bad things to each other. There. So that's a very ugly way to expand the first bit out, but we'll keep on going. So now we've got pi on 3 times h cubed. Right, so just make sure you've got all of that down to this point, and then think about what the next step is. We've now got our volume expression just in terms of one variable, h. So to maximise something, we find where the gradient is 0. Right, so we're going to differentiate and then set the derivative equal to 0. So v equals this. And dv by dh is equal to 484 pi on 3. Don't do anything with the pi's. Leave them as pi's until very near the end. So that's what we've got here. Simplifying again, that's what I end up with. Okay, and we want that to be equal to 0 for a maximum. So that gives me pi h squared is equal to 484 pi on 3. We can divide both sides through by pi, and that gives me h is equal to the square root of 484 divided by 3. Now I'm only doing the positive square root because height has to be a positive number, so we'll just put that down. So ignore negative h value because of the context. Alright, so the last thing we have to do is to get a sensible answer rounded to give a number in centimetres. So popping that now into your calculator, you should get this for h. So h is equal to 12.7 centimetres. And now we're going to substitute to get r, right? So we're going to use the r squared. So r squared is equal to 484 minus that value squared. So try to hold this in your calculator rather than using the rounded value. So that should give us an r squared. Right, I'm going to put dot 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 so you see I'm not rounding too early. That gives me r squared of about 322.6 recurring, and we're going to take the square root of that. Right, so giving us r is equal to 17.96 centimetres, or approximately 18.0 centimetres. I'm going to one significant figure more than the values that I was given in my question. On the last slide, I'm just going to draw a picture of what that looks like, because it's always worth doing a common sense check at the end. Alright, so here's my cone. Now moving back into 3 dimensions. This is 22 centimetres, and the radius is going to be a really, really wide 18 centimetres, and the vertical height is going to be 12.7 centimetres. So the cone that I've drawn is a really inaccurate picture. It looks more like this. Let's try and do it a bit better. Oh, that's terrible. Okay, this height here is 12.7, the radius is 18 centimetres, and the slant height is going to be 22 centimetres. Alright, so send me an email, let me know how you got on with that, or if you've got any problems with it, leave me a comment on the video. I've gone through this really slowly because these 3D optimization problems are quite tricky until you get used to them. So the last thing I really, really want to stress is that you need to be drawing a good picture and often doing a picture of a right angle triangle hiding within the question. Thanks for watching. I'll do another video tomorrow.